All right, here we go. 2016 Module 1 for multiple choice, all 12. So, this question is talking about simplifying square roots. Well, I say in this kind of situation, let's just literally go through every choice to see which one does or would simplify to 4 root 5 if you let x equal to 2. So choice A, if you plugged in 2 for x, this would literally become 2 root 10. Now, does that simplify? If you were doing it Mr. Birchanowski's way, you would try to simplify the root 10 by breaking it down all the way into its prime factors and seeing if there was any pairs of prime factors. Well, 10 breaks down to 2 and 5. There's no pairings at all. So, and then as far as like my method is concerned, you'd want to break off a perfect square factor from 10, which you cannot. So it's not choice A. Moving on to choice B, if you plugged in 2 for x, you would get 2 times the square root of 20. 10x would become 20. Yeah, so if you were doing it my way, now you'd want to break off a perfect square from 20. Like, so what's the largest? And it's key when you're doing it my way to get the largest perfect square factor of 20. And so the 2 comes down, and then root 20 would become root 4 times root 5. Which means if you were doing it Mr. Birchanowski's way, it looks like you would have, you'd have like 2 pairs of 2s. Actually, I take that back. Let me first get this final answer here, okay? Well, with my way, getting back to my way, what is root 4? Root 4 is just 2. And so now I can just do 2 times 2, which is 4 root 5. Anyway, as I was saying about Mr. Birchanowski's way, it seems like, you know, if you were to break down the 20, it seems like you'd have like a pair of 2s, which made the 1 2 come out, and then the single 5 that stayed under there. And hey, it looks like it's choice B, but let's make extra sure. So see, if we were plugging in 2 for x, we'd get 5 times the square root of 4. Well, guess what? Root 4 is just 2, and 5 times 2 is 10. That doesn't simplify to 4 root 5. That reduces to 10. And then if I were to plug in, let's see, for choice D, if I let x equal 2, I'd be getting 8 root 10, which we saw when we checked out choice A. Root 10 doesn't even simplify at all. So well, of course, it was B. Just checking each answer one at a time. Speaking of that, in this question, they try to, again, like put a little twist on a GCF question, and they're giving you one of the monomials, and they're also giving you the final GCF. They're actually, it's like they want you to figure out like the GCF of this and which one of these would get you a final GCF of 3x squared y. Well, let's just kind of go through all of these, I guess. So 3x to the 4th y. What would the GCF be of this one and this one? So the GCF of 3 and 3 is 3. The GCF of x to the 1st and x to the fourth. Remember, with GCF, you kind of go with the smaller of the two exponents. So that would get you an x, and then comparing y to the second and y to the first. So the overall GCF, if you were going with option A, would be 3xy, and that does not match. Well, what's the GCF of these two? Between 6 and 3, the greatest common factor is 3. When you compare x squared and x to the fourth, you get x squared. And when you know the smaller of the two exponents with GCF, remember, this is a side note, with finding LCM of two or more monomials or something, you would go with the larger of the two powers. But here, when we're doing GCF of these two things, we're taking the smaller of the two exponents for the x's, and now the smaller of the two exponents for the y's, which would just be 1, y to the first power. And it seems like that's going to be it. But just to make sure, what would the GCF be here? Well, we got 3 between 3 and 9. Between x to the fourth and x to the sixth, the smaller power is 4. All right, so we see it's not C, just to confirm. And then for D, it would be 3, but then x to the fourth again, and then y. So again, it turns out that when I checked this with all the possibilities, it turned out that the correct GCF came from B. So look, it's just, you got to be ready to do all different kinds of strategies, and remember, multiple choice, oftentimes the only real strategy would be just to kind of check each answer. Now, let me grab my calculator, because here they're talking about, I don't know, I guess this counts as an estimation problem, but you basically, let's see here, Sun to Mercury, Sun to Saturn, and the speed of light is 300,000 kilometers per second. So, oh my gosh. Well, please notice the per second thing, and then for the final answer, they want the best estimate between the number of minutes. So we're eventually, it's going to be a matter of like converting or whatever between seconds and minutes. So here we go. Let's figure out how many seconds it takes for light to go from Sun to Mercury and from Sun to Saturn. So here's what we do. We take these two values and we divide them both by 300,000. And that's going to get the number of seconds it takes for the light to travel from Sun to wherever. So here we go. 57,909,227 divided by 300,000. And so from the Sun to Mercury would be 193.03 seconds. Okay? Now I got to do 1,426,666,422, and I'm going to divide that number by 300,000. And so that's going to be, what is this? So that's like a number of seconds. Right? this was total number of kilometers. Speed of light goes 300,000 kilometers per second. So this is from the sun to Mercury. And this is how many seconds it takes for light to go from the sun to Saturn. Now we're going to be comparing a number of minutes. So how do I convert seconds into minutes? I divide by 60. And so when I divide 193, and again, we're estimating, so I rounded this and I rounded that. But don't round too much. Like, you want to save most of the rounding, or if you can, you want to save like all the rounding until like the way end, but I think we'll be good. So here we're talking about approximately 3.217 minutes, and over here 4755.55 divided by 60, and that gets about 79.259 minutes. And I don't know what it is about the keystones with, like, what the heck did it say? Wait a minute. Which amount of time is the closest of the difference? I'm surprised they didn't say how many more minutes does it take. So it's like an extra step that they want you to do. I don't know what's with the keystones with this stuff, but so we do have a final step, which if we do 79.2-ish minus 3.2-ish, aren't we going to get like 76? So when I mean, they're both 0.2, so you could literally subtract these two decimals I have, but you're going to get pretty much about, remember, where does it say estimate? Closest estimate. So about 79. Again, you want to round at the way end and save all the rounding for the way end, but I mean, look at these choices. So 76. So I guess the best answer would be 80 minutes. B. All right, well, just simplify what they have here. Now, you're definitely going to want to make sure you distribute that negative sign first, or in other words, like distribute the -1. There's nothing really to distribute here. I mean, so look, long story short, you can just kind of make this into, what's minus minus? That's going to be plus x squared minus 6x minus 4. If you're thinking that we need to like do some kind of crazy extra foil type thing, or that we have to distribute all of the, no. This does not say this bubble times this bubble. It says this bubble of terms minus this bubble of terms. The only thing you're going to distribute is this minus sign. And now you're just going to look to combine like terms. So we got this and this are going to be like terms. So that's going to be 4x squared. We have the plus 2x and the minus 6x are going to combine into minus 4x. And then we have -8 and -4, which are going to combine as like terms to make minus 12. So the answer is D. Once again, the only distributing is that minus sign. It's not bubble times bubble. We're just subtracting that whole bubble. Number 5, having read this already, you have, they're explaining a situation, and they want you to pick the equation that models what's going on. So, very important, as always, please pay attention to the fact that the D variable represents number of days, and the H variable is filling in for the unknown height, the varying height. So considering that we're growing 0.05 centimeters per day, so wouldn't it make sense to multiply the 0.05 and D, since D is the number of days? Doesn't that make sense to multiply those together? 0.05 centimeters for each day times D days. But we started at 2, so wouldn't we want to tack on like a one-time amount of 2 centimeters? So I'm thinking A. Because, just to kind of say this out, the overall height would be the number of centimeters we're growing each day times the number of days plus the 2 centimeters we started at. And so it should be A. Number 6, they want you to identify the property of the missing step, right? So looking at this, like, what would you do from here? Wouldn't you distribute, right? I hope you would see that the missing step would involve the distributive property, because we are distributing the -3 and we are distributing the 5. And so, just to double check, I mean, I'm just making sure that it is D. Yeah. Gang, I mean, in questions like this, I know they mention all kinds of different properties, associative and whatever, but the distributive property is most likely going to be the property they want you to be able to recognize. Number 7. Okay. Number 7 talks about Sylvia learning a new language. Again, look, how many words is Y? How many days is X? And so they give you an equation that describes Sylvia's learning a new language. And so here's the equation. And then they say this ordered pair is a solution to that. So look, this is literally X and this is literally Y. And so the solution just means that X equals 6 and Y equals 48, which means what was X? X was a number of days. So it's 6 days, and the Y was how many words? So 48 words. And I think they're just looking for this answer that literally says that. So that would be C. I mean, come on. If again, an ordered pair solution is literally an X value and a Y value. So that means 6 days, 48 words. Just please always notice what the variables represent. Number 8, Christine sells a total of 50 tickets to a school play. All right. Student tickets are $150 each. Adult tickets are $4 each. Christine made a total of $112. Christine writes a system of equations. Which statement best describes the solution? Wow, okay. They're talking about the solution, so it looks like we're going to have to not only write this system, but solve it. All right. Wow, I don't think we've done this before in one of these videos. So we need variables. Variables that represent the unknowns. So what are the unknowns? Well, we don't know how many student tickets were sold, and we don't know how many adult tickets were sold. So I'm going to use the S variable and an A variable. Now just don't make, I'm going to use my S, I'm going to use the letter S. I'm just going to make sure I don't have my letter S's look like 5s. I mean, I don't like using the S variable, but I'm going to. So here we go. If S is my unknown number of student tickets and A is my unknown number of adult tickets, well, I know there was 50 tickets total, so that means that if I do A, my unknown number of adult tickets plus my unknown number of student tickets, I know that should add up to 50. And I know that if I multiply my adult tickets by 4, that tells me how much money was made by selling my A number of adult tickets because you're going to multiply it naturally by how much it was for each ticket. And then I'm going to want to multiply S as my number of student tickets by 150. Because doing this multiplication will get all the money I made from selling just student tickets. And then when I add those together, I get my $112.50 total. Okay? And so now that I have a system and they want me to speak about the solution, well, I need to solve. So once again, I'm going to choose the elimination method, which means I'm going to want to add my equations together, but not unless my A's are opposites and will add up to 0, or my S's are opposites and will add up to 0. They are not. 1A and 4A, not opposites yet. 1S and 150S, not opposites. So what I'm going to do is create opposites using the A's. And what is the opposite of 4A? Negative 4A. So I got to make this into a negative 4A. How do I do that? Easy. I multiply this entire equation by negative 4. Remember, this negative 4 gets multiplied not only to here, but also to here, and also to here. And my bottom equation can stay the same. And now that I have opposites, now I can go ahead and add my equations together. So what's negative 4 plus 1.5? That should be 2.50 or 2.5, right? Yeah, it should be. I mean, see, that's why you should do things on your calculator. Got to follow my own advice. Let me just double check. Negative 4 plus 1.5. Negative 2.5. You know what? If I hadn't caught myself there, I would have probably caught myself on this next step part. So negative 200, okay, calculator this time. Negative 200 plus 112.5, that's going to be negative 87.5. And now I'm going to want to divide both sides by negative 2.5 or negative 2.50. Divided by negative 2.5. And so I get S equal to 35. So remember, S was the number of student tickets. So 35 of those tickets. And when you look at maybe plugging it back into this equation, or just remembering basically that when you get 50 tickets total, 50 tickets total. So that means that there was 35 students and 15 adults. And you could have literally replaced 35 in there, or replaced the S with 35, and then subtracted 35 to both sides, solving for A. So, okay, here we go. Choice A. Christine sells 35 student tickets and 15 adult tickets. Well, that seems like it's that. But let's check B. Christine would earn $200 by selling 50 adult tickets. I mean, that's true, but... Okay, this is interesting. That's true, but here's the thing. That doesn't describe the solution. You know, all that reading creates this system. You know what I'm saying? And this system has a solution, which we just found. And so even though I think B is saying something true, that doesn't describe the solution to the system that we write. Part C, Christine sells a pair of tickets for between $3 and... what? What? I mean, I guess that's true, but doesn't describe the solution. And then D, Christine could not earn $112 by selling 50. I don't know. I'm going to say that's probably true. You know what? Hindsight being 2020 here, you probably could have figured out that it was A just by seeing that the only answer that was talking about what would actually be describing a solution to what the system would, I don't know. I think it was good practice. It was, and I don't regret doing this the long way or anything like that. We also could have done, I was going to say work the problem backwards from the choices, but I like what we did here. I like actually writing the system, solving the system using the elimination method, which I call the addition method, and figuring out that the best answer is A. Number 9. Hopefully you've read it already, but I have to read this. A plain pizza takes 10 minutes to bake. All right? At least. That is key verbiage right there. At least means like greater than or equal to. Anyway, at least 2 minutes of baking time is required for each ounce of toppings added to the pizza. The total baking time for specialty pizzas is at least 18 minutes and at most 26 minutes. That's a less than or equal to type thing. Which graph shows the possible number of ounces of all the toppings on specialty pizzas? Alrighty. This one's kind of interesting. I would say because of the whole at least, at most thing. See how these are like open circles? I would already be pretty confident about taking off or disqualifying choice B and choice C. Number 9 is not that easy to wrap your brain around, is it? So here we go. Because I'm assuming this whole specialty pizza thing is adding a number of toppings. You know what I mean? So, look. What I'm going to do is just sort of think about this thing, like sort of reverse, like work this backwards, and think, well, we added a certain number of toppings, and it looks like, let's see here, at least for each ounce of toppings, the total baking time for specialty pizzas. I don't like the way this is worded at this time. Which graph shows the possible number of ounces of all the toppings on specialty pizzas? Alright, well look, here's what we're going to do. We're going to subtract 10 minutes from this low number and this high number, okay? And that's just going to leave like the toppings, you know what I mean? So it takes 10 minutes for just like the plain pizza to bake. So if you subtract 10 from here and from here, you get a new sort of interval range of, let's see, between 8 and 16. Okay? So and hopefully you're kind of understanding what's happening. So if you subtract the 10 minutes for just like the plain pizza, now you get like, well, we need like 8 extra minutes for like the number of toppings and 16 minutes maximum extra for like a high number of toppings. So there was like at least 2 minutes of baking time for each ounce of toppings. So I'm now going to like divide both of these by 2, like minutes by 2, because it was like 2 minutes per ounce. And so if you now divide both these by 2, you get basically between 4 ounces and 8 ounces. And so because of like the whole, remember, at least, at most, we have like this or equal to thing going on. And so for that reason now, like, we are between 4 and 8. Okay. That one was heavy. Number 10. A lot of reading here, which I hope you've already done, but I'm kind of going into this one a little cold, so bear with me. Cleaning service offers its customers a choice between 2 plans. Plan A, okay. Plan B, all right. Henry, let's see, plans on. All right, so here's the which plan to choose based on the number of cleanings C. Number of cleanings C. Based on the solution in the cornerstone. Okay. If we solve this for C simply by dividing both sides by 75, well, first let's say this. All these is about 1 year. So he could either spend $3,000 for 1 year and just get whatever, right? How many number of cleanings he wants. Or he could do like 75 times the number of cleanings. So we're going to pretty much see like which one's larger. 75 times this number of cleanings or just $3,000 flat out. So that's why this is set up that way. You know? Because listen, if the number of, like, we're basically about to figure out what would the value of C be? Like, how many cleanings would it take for this amount to be larger than just 3,000? So we're gonna figure out like what breaking point that is. And so when we divide both sides by 75 on my calculator, we're going to get, let me just write this down, all right? Why don't I just write this down? I get 40. All right, so once the number of cleanings exceeds 40, then it just seems like going with the 3,000 is the smarter thing to do. Because if we're going to get like 41 cleanings, then we'd have spent more than $3,000. Anyway, so let's look at the choices. Henry should choose Plan A only if he expects to need fewer than 40 cleanings in a year. Fewer than 40, that would not include 40. I don't know. Let's not get that strict. So yeah, only if we need to. So choice B. Henry should choose Plan A only if he expects to need more than 40 cleanings. Henry can choose either plan if he expects to need fewer. Henry can choose either plan if he expects to. No. I wouldn't say it's there. So let's make sure we're picking the correct one, A or B. Henry should choose Plan A. So this is Plan A, right? Only if he expects to need fewer than 40 cleanings. No, because if he expects to need more than 40 cleanings, yeah, it's B. I mean, I'm pretty sure. Just the reading part, man. Like the reading comprehension, you just got to read it more than one time sometimes. Because if he was going to need more than 40 cleanings, then that would have him spending more than $3,000, and so he should just, yeah, so it's B. Okay, oh boy, number 11, Kelly. All right, she's going to stay no more than 5 nights on the trip. She estimates each night she stays at a hotel will cost $90 and each night stays at a hotel in Boston. All right. She wants to spend no more than $540 for hotel stays. Which graph represents the possible combinations of nights she can spend in Hartford and the nights she can spend in Boston? Why? All right. So X is the unknown number of nights in Hartford, and Y is the unknown number of nights in Boston. So, okay. So I'm going to go over here and say, like, okay, well, no more than 5 nights total. So that means if we add up the number of nights in Hartford with the number of nights in Boston, that should be no more than 5. So that needs to be then less than or equal to 5, which is the mathematical translation of no more than 5. And so now we want to spend what? No more than $540. So if X is the number of nights in Hartford, then wouldn't we do 90X? We would multiply $90 for each night times X number of nights. And then we would also want to do 120 times Y and multiply the cost for a night in Boston times the number of nights in Boston, Y. And that needs to be no more than 540. Okay. So now it's like we need to figure out which one of these graphs is the graph of this system. Well, I know essentially what are we going to do? How do we know which graph is correct? Don't we need to kind of put these in like mx plus b form? Now this one, all you really have to do is subtract x to the other side, which is going to get you y is less than or equal to negative x plus 5. All right? But this one, let's see here. If we work to get y by itself, we're going to have negative 90x plus 540. All right, sorry, I miscalculated. Well, you know what? Ah, come on, man. Plus, what was this? 5. Look at that. And then dividing both sides by 100. Wait, what was I doing here? That should be a less than or equal to. And so, y, well, I'm going to come over here now, I guess, to the left. Don't forget, people, you have to divide both of these terms by 120. So over here I'm going to get y is less than or equal to, all right, negative 90 divided by 120. That's not clean division, so that's going to stay as a fraction, but can that fraction reduce? Negative 90 over 120? Yeah, that should be negative 3/4 x. And then the 540 divided by 120, yeah, gosh, what is that? 540 divided by 120, that should be 4.5. Okay? Oh my God. You know what? Once again, hindsight being 2020. But you know what? I'm not going to have any regrets because I'm glad I did all this. It was good practice, but man, hindsight being 2020. Look, you know what? You know what I just realized? And, hey, maybe I should have realized this earlier, but again, I don't care. Now I'm looking at these lines. They're all the same. A, B, C, D. Literally the only thing different from graph to graph to graph, from A to B to C to D, is the shading. Right? Anyway, but it was good practice. And it was, good review. So now what you do is you would now graph both of these lines where B value of 5, M value slope of -1, and then this y-intercept for this other solid line. Because again, if the symbol is got an or equal to, the line is going to be solid and not dashed. So you notice how these lines are solid like they should be for both of the lines? But what about the shading? Because that's going to be, I guess, the ultimate, only deciding factor now that I realized. But the shading shouldn't, well, for a less than or equal to, and what would the shading be? Like, where would you shade for a less than or equal to? You would shade below the line. So for both of these lines, you would shade below the line. And the final shading for the system would be where you shaded double. So like, which graph represents both of the shadings? It's going to be D. Because that section represents shading below both of the lines. All right? Number 12. A lot of reading, man. So just read all these very carefully. More than once if you have to, please. And again, pause the video if you haven't read this through yet, more than once or at least once. Here we go. I have to read this myself. 2 types of donuts. Hopefully one of them is mighty fine donuts. The best darn donuts around. 25 cents to make each glazed donut, and 30 cents to make each chocolate donut. More than 200 total. Look, I'm going to cut off right there. Look at this. I love it when the Keystones do this. They go through like the entire explanation, and then what they do is they give you the system of inequalities for free. All this is really doing is mathematically explaining all of this. Look, more than 200 donuts total. Look at this. More than 200 donuts total. And then the fact that we want to spend like no more than $60, So this system is already written for you. You just need to figure out that X would need to represent what? Like what would be multiplied to the 0.25? 25 cents per glazed donut. So wouldn't X need to be the number of glazed? And the Y, since it's being multiplied to the 0.30, wouldn't Y need to be the number of chocolate? If I could spell chocolate correctly, that'd be nice. Chocolate. And so all they really want to do is they want to say one solution, big word, one solution of the system is the ordered pair 100, 110. Which statement best describes the meaning of the solution? Okay, people, to finish off this video, if a solution is 100, 110, that means X literally would equal 100 and Y would literally equal 110. So that means 100 glazed and 110 chocolate, because X is number of glazed and Y is number of chocolate. So which choice says that? It's looking like it's A. The baker could earn 100. No, the base and the part's answer C. The baker can make a maximum. No. It's A. Thank you very much.